The next couple of videos will go into colligative properties. And what I'm going to do in this video is let you know what we're going to do and add one tiny detail of how we're going to account for stuff that is in the solution. So colligative properties, this is where we are going to start looking at how solutes affect solvent properties. So if my solvent is water, if I dissolve something in water, how does that affect the properties of water? This will depend on the number of solute particles in the solution. And when we do this, you can ignore the vapor pressure of solids. So, right, one of the things that you were able to find on a phase diagram is the vapor pressure of a solid. Solids can have and do have vapor pressure. However, compared to liquids, the vapor pressure of solids is extremely low. And for our colligative properties, that means that we can ignore it. There are 4 properties that are affected by dissolving solutes in a solvent. One is the solvent vapor pressure. Then there's the boiling point and freezing point. I have these listed as 2 separate, but we're going to talk about them together because they have the same kinds of equations. And then the 4th is something called osmotic pressure, which I'll define for you when we get to that video. The way that we account for particles in the solutions is with something called the Van't Hoff I factor. This will explicitly show up in some of our calculations. In some of our other calculations, you will account for this number of particles kind of inherently in the way that the equation works. But for any case where you see I in an equation, what it's communicating to you is how many particles go into solution from each formula unit that you dissolve. All right, it has this really long, weird equation. I think this is best illustrated with an example. The way that I will ask you to do this, it should be intuitive. I hope that it is intuitive based on what we've done with solutions in the past. So moles of particles in solution divided by moles of formula units that are dissociating. So let's say that I am dissolving sodium chloride. If I take 1 sodium chloride and I split it up, I get 1 sodium and 1 chloride. The Van't Hoff I factor for this is 2. I took 1 formula unit. When I put it into solution, I had 2 things. So the moles of particles in solution, there's 1 sodium and 1 chloride divided by moles of formula units dissociated. I got those 2 when I dissolved 1 mole of sodium chloride. Now this is in a perfect world. We don't have a perfect world, so depending on what's going on, we may not get this perfect world Van't Hoff I factor. However, when I give you questions that have where you have to consider the Van't Hoff I factor, you can either 1, assume that it is a perfect world, or 2, that is the thing I will be asking you to find. So if you need to come up with the I factor on your own to put into the equation to solve for the answer, then you can assume that it's a perfect world. Otherwise, the question will be asking you to find the I factor for the solute based on the outcome of the solvent properties. A non-electrolyte, right? So my I factor is really, it's only going to get complicated when I have things splitting up into ions. But things that dissolve without breaking up the molecule, so things like glucose, which are non-electrolytes, the Van't Hoff I factor is 1. So the I just kind of disappears officially from the solution. Technically, it's a 1 because it's a non-electrolyte.